Hello students. Okay, what we're going to do now, since we've now worked through how to solve equations all the way from simple one-step equations up to some quite complicated ones involving brackets and fractions, what we're going to look at now are just some fairly straightforward word problems that require linear equations to solve them. So let's have a look at this one to start with. So just reading it out, and I'll do some underlining as I go. Subtracting 11 from 4 times a certain number gives the same result as subtracting 2 times the number from 7. Write an equation and solve it to find the unknown number. Okay, well, if we're going to write an equation, we need to use a variable for our unknowns. I'll use the letter N to stand for number. So I'll start by just writing unknown number equals N. So whenever we're solving word problems, the first thing we have to do is define our unknown using a variable. Okay, subtracting 11 from 4 times a certain number. So 4 times a certain number is 4n, and I'm subtracting 11 from that. So 4n, take 11, gives the same result as is a fancy way of saying equals, and the rest of the sentence, subtracting 2 times the number from 7. So we're not subtracting 7 from twice the number, we're subtracting twice the number from 7. So you do need to read a little bit carefully. And that's the hard bit done. Okay, we've now managed to get from the English question to the equation. Now we've solved ones like this in previous videos. We've got 4n on the left, subtract 2n on the right. The opposite of subtracting 2n is adding 2n. And again, we do it to both sides. Minus 2n plus 2n goes to 0 or cancels out, leaving just a 7 on that side. 4n plus 2n is 6n. And we just copy down, subtract 11. Okay, now we need to add 11 to both sides. We always add or subtract first when we're solving equations. Minus 11 plus 11 goes to 0, just leaving us with just 6n. And 7 plus 11 is 18. And finally, the last step, just divide both sides by 6. And our solution is n equals 3. Now, when we're checking this solution, I think it's important not to check it against the equation, because I might have made a mistake in writing this equation down. For example, I might have written down 2n take 7 rather than 7 take 2n, and then solve that equation correctly, but it's not going to be the correct answer for solving the original question. So to check it, we always go back to the original question. So let's go ahead and see how it works out. Subtracting 11 from 4 times a certain number. Well, 4 times 3 is 12, and I'm subtracting 11 from that, so that expression has a value of 1. I think I'll just write it as a normal 1 rather than try to do a fancy one. And that gives the same result as subtracting twice this number from 7. Well, 2 times 3 is 6. Subtract that from 7, and we also get 1. So yes, that does check out. That is the correct answer to that particular problem. Okay, I'd like you to try this one on your own. So read the question, stop the video, and when you've got it finished with all your setting out and checked it, start the video and we'll see how you went. Okay, welcome back, students. Well, once again, we have to first say we've got to give that a variable name. So I'm just going to say the unknown number is equal to n. Okay, now that number is being added to 36. So I could write 36 plus n, but it's the same as writing n plus 36. So I prefer to write my variable first. Gives the same result as, once again, just means equals. And the last part of it says adding 6 to the number and then doubling the result. So add 6 to the number, and doubling the result means we have to put it inside of brackets. So a certain number, when added to 36, gives the same result as adding 6 to this number and doubling the result. So there's the hard step done, which is getting from the English to the equation. To solve it, the first thing we have to do is expand the brackets. So that's 2 times n plus 2 times 6. Now this, of course, is just one n, so I've got an n on both sides of the equation. I'll take one n from each side. Those cross out. That leaves just 36 on the left. 2n take 1n is 1n, or just n plus 12. And just a one-step equation to solve. Subtract 12 from both sides. I'm now going to write the n over on the left-hand side, and 36 take 12. I'll put that on the right-hand side. So the answer to our problem is 24. Let's just check it to make sure we haven't made any mistakes. So a certain number, when added to 36, so that's 24 plus 36, and that gives us 60. Gives the same result as adding 6 to this number and then doubling the result. Well, 24 plus 6 is 30. Doubling the result also gives us 60. So n equals 24 is the solution to that equation. Okay, now this equation is actually quite easy, but there aren't too many students that I've taught that when they're seeing a question like this for the first time, will know what to do to start. So once I show you how to do this one, there's a similar one on the next page that you can have a go at on your own. So find 3 consecutive odd numbers that sum to 195. In fact, it's quite easy to do in your head, but we're interested in getting the correct algebraic expression for it. So the first thing is I'm going to decide which of those 3 odd numbers I'm going to call n. And usually I prefer to choose the smallest number. So the smallest unknown number is n. The reason I prefer to use the smallest one is it means that I'll then be adding something to get the other 2. And I always prefer to have additions rather than subtractions if I have a choice. Okay, so the smallest number is n. Now what a lot of students want to do in this case is say, well, the next number has to be O, and the third number has to be P. So they want to try to use the 3 letters of an alphabet. But what we're going to try to do, what we have to do, excuse me, is to get all of these numbers in terms of the one variable. So the next number is not going to be the letter O. Because they're consecutive odd numbers like 1, 3, 5, 7, 9, what we know about odd numbers is they're 2 apart. So the next number has the expression n plus 2. So whatever the smallest number is, say it's equal to 6. Sorry, say it's equal to 7 because it's an odd number. The next number has to be 7 plus 2 is 9. And you can probably guess what the largest number is going to be using the same reasoning. So the largest number is going to be 2 more than that. Well, n plus 2 is n plus 4. So what we had to do in this case is to write each of the three numbers that we don't know, all in terms of one variable. Okay, now the second part of the sentence says that they sum to or add to 195. Well, that means we have n plus, I might put it in brackets, don't have to, but it just keeps that sort of together. So n plus 2 plus n plus 4 equals 195. The sum of the three consecutive odd numbers adds to 195. And again, the brackets here are optional. Okay, let's go ahead and simplify that. Well, n plus n plus n is 3n, plus 2 plus 4 is 6, and that adds to 195. Now we have a two-step equation to solve. We've done these before, so we subtract 6 from both sides. They cross out. 3n equals 189, and divide both sides by 3. I might just write the answer over this way to save having to scroll, and n equals 189 over 3. And that will simplify. 3 goes into 18 6 times, 3 goes into 9 3 times, and it looks like the answer is n equals 63. Okay, let's do a quick check over here. If the smallest number is 63, the next number is 65. It's the next odd number, and the next odd number is 67. 3 plus 5 is 8. 8 plus 7 is 15. Carry the 1. 6 plus 6 plus 6 is 18. Plus 1 is 19. And it does check against the 195. So n equals 63 is correct. So what you expected to do for this question is not do it in your head. It's not that hard to do that way, but to practice using algebra to solve questions like this. Okay, your turn to try this question. 6 consecutive multiples of 7 that sum to 609. So you've got to think about how far apart each of those multiples of 7 are. Okay, stop the video, have a go, solve it using algebra, check your answer, and then come back and see how you went. Okay, let's go through this fairly quickly. It's much the same as the last one. Once again, I prefer to, here's my symbol for number, by the way, when I get a bit lazy. Smallest number equals n. Next number. Now, their multiples 21. Each of those numbers is 7 more than the previous one. And then the third number, n plus 14. The fourth number, n plus 21. That's 4. Keep going. Next number is n plus 28. Next number, n plus 35. That should be 6 numbers. 1, 2, 3, 4, 5, 6. And that's all we need. Oh, well, I'm just going to go ahead and add these vertically, I think. And that's going to give us n plus n plus n plus n plus n plus n is 6n plus, okay, 7 plus 4 is 11. 1 more is 12. 8 is 20. 5 is 25. So I write down the 5. Carry the 2, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I think I've got 6n plus 105 adds to 609. So I think I've got my equation. Okay, I'll take away the 105 from each side. They cancel out or add to 0. 6n equals, well, 9 take 5 is 4. 60 take 10 is 50. Divide both sides by 6. And again, I'll just bring it over here. N equals 504. Divide 6. I could use a calculator for that, but I think I'll do it in my head. 6 goes into 50 8 times, so it's going to be 80 something. 6 times 80 something is 480. And then I've got another 24 to make 504. So I think n's going to be 84. Again, you'd be allowed to use a calculator on an exam for that particular step. Oops. Let me try that again. And once again, I'm going to check it. I'd probably use a calculator to check it, being a bit lazy. So I've got 84, add 7 onto that is 91. Add 7 onto that is 98. Another 7, 105. Another 7, 112. And another 7, 119. So there's our 6 consecutive multiples of 7. And I'm going to add them up in my head. Yep, I get 609. How about that? So that answer, in fact, is correct. Okay, those were, like, I guess you might call them sort of mathematical word problems. So in the next video, we'll be looking at word problems that are a bit more realistic and a bit more lifelike.